And now in this section, I'm going to talk about a liquid application after cooling. Remember that when we are applying liquids at the die, we are applying those liquids before cooling. So let's discuss some system after cooling. And then this is going to be done before placing the feed into the finished feed bins. So some of the application methods are going to include a spray into a screw conveyor and also using a spinning disc to automize and apply the liquids. Some of the advantages of this system is that usually the liquid is applied before the pellets goes into the finished feed bin. So there is going to be less chance of a contamination, and also there is going to be a lower risk of cross-contamination if you are applying drugs. Some of the disadvantages of these systems is that typically these systems are on the top of the feed mill, so access can be a concern. So here you can see some examples of post-pellet liquid application systems, and what you can see here is like the surge. Then here you got the feeder. The motor is going to have a BFD, so this feeder can move faster or slower. Then here you got like the scale, and the scale is what is going to be weighing the dry product, and depending on the amount of dry product that is going through the scale, then the system knows how much liquid it needs to apply into the spinning disc. The spinning disc are going to atomize that liquid, and then that liquid is going to be absorbed by the pellets. So some of the components of post-pellet liquid application systems are going to include the dry flow measurement, the liquid measurement, then the spraying and coating, and then the mixing. So I'm going to walk you through the system here. You have a surge hopper, so the feed, as the feed leaves the cooler, is just dumping into this surge hopper. Then here, this system is going to have a scale that weighs the pellets, and then depending on the weight of pellets, then the system knows how much fat it needs to apply. So fat application is going to be here at the bottom, and then you have the mixing conveyor here. The idea of the mixing conveyor is to allow the pellets to absorb the liquids. Then you got some distribution conveyors, and then you got like the loadout bins underneath. The dry solids flow measurement is critical to ensuring that the PPLA system correctly dose the liquid ingredients, because if we are not weighing the dry pellets correctly, then we are not going to be able to apply the correct amount of liquids. And we need to determine if the device is density dependent or independent. As I mentioned before, when the devices are density independent, they are going to be better, because you don't have to be checking how the density of the feed changed when you change a formula. In general, systems that are density dependent cost significantly less, but density of the dry solids must be constantly monitored. And this is what I mean with my previous statement. If you can have like devices that are density independent, that would be better. So with the dry flow measurement, you can have like different alternatives. You can have a weight belt, as you can see here. So all the pellets are moving in this direction, and you can see that there is a load cell here, and this load cell is weighing how much is going through it. Also, you have the weigh screw, and basically it's similar to this one, but this screw is going to be over on a scale, and the system is going to be weighing how much is going through the screw. Then you have this impact scale. Basically, as the feed is coming from the cooler, is falling through a transition, and this transition is hitting this impact scale, and then you can calculate that way how much pellets are going through the system. And then you have the centriflow, which is the system that we have in our feed mill, and you can see here the centriflow. So as the pellets are dropping, then all pellets are touching the centriflow, and then this is calculating or is measuring the dry flow. And then you have a liquid measurements, and as I mentioned before, you can use positive displacement pumps when you are pumping from the fat tank to the mixer. Also, you can use Coriolis meters, and this is an example of a Coriolis meter, and this is an example of a Coriolis meter. And the material moves through the bent tubes, and this creates a vibration frequency that can be measured and calibrated back to a quantity of liquids. Changes in viscosity, temperature, and density are accounted within the meter, which allows for a more accurate measurement of the liquid. So in our system, when we are applying liquids post pellets, we are going to be using these Coriolis meters. And the other alternative is also to have a loss in weigh scale. Then the next component, right, once that you weigh the dry material and the liquid, is the spraying. And liquids can be applied using spray nozzles. I'm sure that you are aware with the spray nozzle, just like this. Or they can be applied using this spinning disc. Nozzles generally work on a narrower range of liquid volumes, while this centrifugal disc can handle a wider liquid application range. The other advantage sometimes with this disc is that they are not affected by the density of the liquid as much as the nozzles. So this is some of the application system. You have like a spray into a screw conveyor. Here you can see the conveyor and you can see the nozzles here. You have the conveyor at the bottom. You see the nozzles on top. With these screw conveyors with an spray nozzles, the coverage can be improved with the addition of a spray plenum. This increases the probability of liquids hitting the dry product in an uniform fashion. Some of the disadvantages of these systems is that they don't apply liquid uniformly, and you are going to see like dry spots in the pellets, and then you are going to see some wet spots. So that's one of the disadvantages. Nozzles apply liquid to a limited number of particles, and they can get like this spotty coverage. And also a little mixing action with the standard flights. You can also use an spinning disc applicator. As you can see here, you can see the 3 discs. In this system, you can apply single or multiple liquids through one inlet. So for example, in our feed mill, we can apply 4 liquids using one inlet. And these systems utilize high-speed rotating disc for automation of the liquids, so there are no spray nozzles here. If you can pump, a liquid, then the spinning disc applicator can apply it. And then after, there is going to be a twin screw mixing conveyor that is going to help the pellets to absorb the liquids that you apply. And typically the retention time in the mixing conveyor is going to be between 45 and 60 seconds. So this is the way that this system with, like the centriflow and the spinning disc works. So the coater system is ready to receive the product. Then dry product begins to flow into the inlet. Then dry product begins to transition into the centriflow. Dry product is oriented typically against the tangential plates of the centriflow, and dry product begins to flow across the metering pan. So basically what is happening here is that, as you can see, as this product hits the centriflow, now the system knows exactly what is the rate of dry flow that is going through the system, and now the system knows how much liquid needs to apply. Then a dry product continues to fill the inlets, and then dry product lands on the low RPM rotating dry disk. Liquids continues to flow towards the liquid disk, and dry product begins to fall off the rotating dry disk, and then liquid spray begins. So here you can see you got the pellets here coming in green, and then here you can see the liquids being atomized in red. Then a coated product falls into the conveyor below for further mixing. So here you can see an example of the system that I use the centriflow and the spinning disc, and you're gonna see that the mixing conveyor is gonna start running. You can see it here. Then you're gonna see the spinning disc that are gonna start running. Then the plate is gonna start running. And then you're gonna see the liquid product falling through it. So you can see the liquid product that is coming this way, and then you can see the inlets of the liquids moving in this direction into the spinning disc and then being applied into the dry product. Some considerations that you need to take when you are applying liquid post pellets is that you need to make sure that you have good pellet quality, because if you have a lot of fines, then the fines are going to have a higher surface area, and then they are going to absorb the liquid faster. So you are going to see some differences in the amount of liquid that is contained in the fines and the amount of liquid in the pellets. So you can see in this example, they collect pellets and fines, and then they evaluate the phytase activity at the feed mill, then at the middle pan, and then at the end pan. This is at the farm. And you can see here that when the pellets were analyzed, the pellets contain a lower phytase activity compared to the fines. And this makes sense, as I mentioned, because fines have a higher surface area. The other thing that you need to consider is the application rates, because if you try to apply less than the actual capacity of the system, what you're going to see is that the pump is going to start and stop, start and stop, and then you are not going to apply the liquid correctly. Also, you need to consider the feed processing rates, because that's going to influence the amount of material that is going through the system at any given time. And as I mentioned before, you want that dry flow to be fairly constant. The other part that is important is to evaluate a liquid uniformity assessments, and the post-pellet liquid application system should be checked regularly. Just like in mixing, you should evaluate, the uniformity at least twice a year, and liquid meters and dry flow scales should be checked every quarter. So to do the uniformity assessment, just like in mixing, you need to collect 10 samples. And then these 10 samples can be obtained over a long run to validate the accuracy of the system. Samples should be collected with and without fats in order to evaluate the system. So the important thing here is that if you have some of this PPLA system, you should have like a sampling port at the end of the mixing conveyor. So some of keys to a good coating, one is to keep a constant level of product in the scale or source so the system runs continuously. You want to keep, the good amount of feed here. That way the dry flow here is constant. The pumps are going to do a better job pumping into a constant flow of dry product. Starting and stopping doesn't allow you to achieve a steady state, and is harder on equipment and on electronic. Also, you want to run the mixing conveyor full, and this allows you to take advantage of the mixing action of the screws. So I was telling you before, it's important to run this conveyor full. And you can have a sampling port here where you can collect the sample of pellets. Some maintenance consideration of the PPLA systems. PPLA systems require periodic inspection and maintenance to ensure accurate operation. Check and calibrate the dry flow and the liquid flow rates. This is important. Frequency of calibration might be semi-annual, quarterly, or more often, depending on the quantity of liquids applied and the desired accuracy. At initial startup and periodically thereafter, you need to perform uniformity tests to measure the homogeneity of a liquid application to the pellets. So good PPLA systems should achieve 15% or less coefficient of variation. So remember that your CV here is not going to be as good as in the mixer, but if you are below 15 in a CV, then you are good. Then routinely inspect and clean liquid spray devices and equipment areas where pellets are sprayed and mixed with liquids. Also, as I mentioned at the beginning of the presentation, it's important to have strainers and filters through the system to remove some solids, but these strainers and these filters, they need to be checked regularly. And then you want to do inventory reconciliation to check the amount of liquid that you apply versus the expected application rate. So in conclusion, post-pellet liquid application systems play an important role to reduce the amount of fat added in the mixer in order to maintain a good pellet quality. Remember that better pellet quality is going to be translated into a better animal performance. Post-pellet liquid applications can also be used to add enzymes that are not stable to heat labile ingredients, and medications to reduce the risk of cross-contamination. Thank you very much, and I will be happy to answer any questions that you might have during the Q&A section.